All right, good morning, everybody.
Good morning.
That wasn't bad. All right, that wasn't bad. All right, welcome to Grand Rounds, and this is one of our special Grand Rounds. And before I introduce Dr. Baker to introduce our guest speaker, and I wanted to say welcome home, Dr. Adachi. It's good to have you back in the hallowed halls of Hopkins. But let me go through the usual announcements, and I want to say a couple words. This is the Shackman lecture, and I would like to say a few words about Susan Shackman and the Shackman family. So the attendance thing for the faculty who are getting CME credit and all that is 56440, and Andrea will put that in the chat room for those who get on the Zoom just a couple minutes late. I'm not going to run through all of the CME announcements, which you are all so familiar with. And I'm sure our guests, oh boy. And of course, all of our lectures are recorded on the cloud for those who are clinically busy. So it's REI. So congratulations to a couple of our faculty members at the SRI meeting recently. Mustafa Borje was honored with the SRI President's Achievement Award, and Jim Seeger's got some other recognition, received the Distinguished Scientist Award. And so congratulations to Mustafa and Jim, and these guys. They bring great credit, not just upon themselves, but upon their division and the department. So thank you guys. Congratulations. One of our fellows just put a publication out this week, so congratulations to the Eurogyne team and Dr. Hope. The last GORS seminar of the year, I think. And again, a big thanks to Dr. Seegers and Miriam and everybody, Dr. Hand, everybody involved in this program. And our very own Carolyn Suffren's going to talk about creating and fiscally managing grants. And, despite the chaos going on in the NIH these days, we were just shocked and thrilled to see a notice of award for Dr. Suffren last week. So she just keeps racking them up. Pretty soon she'll catch up to Seeger's 10 or 11 grants. Congratulations to our fetal therapy team, particularly Dr. Miller, who's got a webinar going on next week, an international webinar. So, and it'll be broadcast through the Hopkins thing. So just to update you on a few things. And before I turn it over to Dr. Baker, this is the 37th annual Shackman Award, and it's kind of strange for me not seeing Dr. Shackman in the front row. He passed away, unfortunately, a couple of years ago. And so thank you all for joining for us. This lecture was established some almost 40 years ago by the Shackman family and their friends to honor the work, the life, and the dedication of Dr. Shackman. She was, at Hopkins in the 60s and the early 70s. She had a number of jobs, but her real thing is she was a grad student in the Bloomberg School, and she was in the process of writing a book exploring psychological aspects of in vitro fertilization, and at the origin of in vitro fertilization. And it was an important and innovative work that unfortunately was never completed due to her untimely death. And this lectureship was established by the family and friends to celebrate her contributions to Hopkins and the promise that she brought that was taken from her at a very early age. And Al Shackman was here for the first 10 years that I was the director, and he was always sitting in the first row, and this was such an important thing for him and his wife. And I'm sorry, I know they're not with us physically here today, but they're here in spirit. And so without further ado, I'm going to turn it over to Val, and I think the Shackman family would just be thrilled with this lecturer today.
Thank you, Andy. It's my great pleasure to introduce Dr. Ali Adachi. He's currently professor of medical science and former dean of medicine and biologic science at Brown University. Dr. Dashi was the very first in the very first class at Tel Aviv University School of Medicine and graduated from there. He then completed his residency in obstetrics and gynecology at Tufts, and he started his fellowship training in REI here at Johns Hopkins. He finished up his fellowship training at UCSD when Drs. Georgiana and Howard Jones had their forced retirement, and he finished it up under the direction of Sam Yen, who the REIs in the group will know as Yen and Jaffe, are one of our key textbooks. Dr. Adachi then joined the faculty at the University of Maryland where he was there for about 15 years, and at that time doing quite a bit of basic science research. He then moved to University of Utah, where he was chair, and then in 2004 to Brown University. Dr. Adachi has like a 150, 200-page CV, and in the interest of time, I will not let you know all of his hundreds of accomplishments, leadership positions, in our field, as well as in medicine in general. But I will mention that he was elected as a member of the National Academy of Medicine and the National Academy of Sciences. He's mentored over 50 postdoctoral trainees and fellows, has over 900 peer-reviewed publications and book chapters. And on a personal note, I recently learned that he's also been a pianist, performer, and composer. And he continues to have a bit of a Hopkins tie in that his son is a composer and here on the faculty at Peabody. So we're very, very interested in this provocative topic that you'll be speaking with us about, as you've really been a leader in so many issues in health policy, and we're eager to hear your talk. Thank you, Dr. Dashi, for being here.
Thank you, Val. Thank you, Andy. Thank you all for joining us this morning. It does feel like the old times in many ways, except I'm approximately 50 years older, which even for me is hard to fathom. Today, though, we will speak about the future. IVG is ahead of us. I don't think it will replace IVF, but I think it will modify it dramatically. But IVG is really just one example of converting one cell type into another. Let's say a somatic cell type into a sperm or an egg, but also you can imagine virtually any transformation that comes to your mind once this technology is perfected. And I will try to illustrate that today by showing you an example that I would not have thought would be possible as recently as a few months ago. I think you'll be just as stunned at what the technology of converting one cell type into another can accomplish. Of course, the main focus will be on reproduction, because that's what we are all here for. I'm showing here a sentimental photograph of the time when I was a fellow here at Hopkins. The Joneses are, of course, seated. The fellows are standing in the back. Next to me is Dr. Zev Rosenbachs, who is now at Cornell. And next to him is John Rock, who spent some time at Hopkins after the fellowship and then wandered around. He is presently in Saudi Arabia. That's the last information we have. We don't have precise details on his mission, but he's, of course, retired, and he himself was a dean at one point, not too long ago, in one of the Florida schools. I was finally able to thank the Joneses in person in 2000, when I was the president of what was then known as the SGI, now referred to as the SRI, and I was able to personally thank them for really how they invested in their fellows, including myself, and the memories I cherish to this day. As you may know, both of them, of course, have passed away. Regrettably, their oldest son also sadly recently passed away. I'm still in close touch with their daughter, Georgiana, who is a Hopkins-trained pediatric endocrinologist who lives in Denver. But clearly, as time goes on, the principles in question gradually disappear, and that will one day include yours truly. But before we launch into IVG, it's good to at least take a brief look at IVF. And remember that in 2028, we'll be celebrating the 50th anniversary of IVF, which we tend to forget. But as you know, of course, Louise Brown was born in 1978 in the UK. This is the paper by Steptoe and Edwards in the Lancet, a letter to the editor, announcing the birth of Louise Brown, all of which now seems so obvious and so familiar, but at the time clearly was major news. And here is the lovely Louise in the arms of her mother, Leslie Brown. In 2010, the Nobel Prize Committee chose Bob Edwards to receive the Nobel Prize. You might ask, why were Steptoe and Jean Gerdy excluded, if you will, from the honor? And the sad reality was that both of them passed away by then. And it is the policy of the Nobel Committee to award the Nobel Prize only to living recipients. That said, Professor Edwards was hardly well at the time and couldn't actually go to Stockholm to receive the award. Ultimately, it was his wife who flew to Stockholm and received the award on his behalf. Professor Edwards ultimately passed away in 2013. This is the Lancet obituary that was written at the time. And we now move, of course, to the US, which was 3 years behind, as you know, in the IVF arena. And here again, we have to thank Howard and Georgiana Jones, although this time operating out of Norfolk, Virginia, and achieving the first American pregnancy on December the 28th, 1981. Here they're shown embracing Elizabeth Jordan Carr, who was the first American baby born in Norfolk. And of course, you can imagine that Elizabeth was displayed in virtually any medium available in the United States. Here she's shown in a lovely photograph in Life magazine. She is now a 40-plus-year-old woman who frequently attends the ASRM and with whom I'm still in touch, and whose mother I interviewed, and that videotape is, of course, available. But going forward, as I said, I think the next iteration of IVF will be the one that is modified by in vitro gametogenesis. In a word, IVG is about converting a stem cell to a reproductive cell, be it an egg or a sperm. And the beginning, which is still true, is purely Japanese. two investigators of significant capability, Mikinori Saito and Katsuhiko Hayashi, have begun this project and continue to develop this project. There is really very little activity in this arena in the United States for a variety of reasons, including quote unquote congressionally mandated ones and others. But apart and distinct from all of this, these two individuals whom I had the pleasure to meet in Kyoto and spend a day with back in 2010, which is when they were already at it, if you will, they deserve really virtually all of the credit. And as is true of any new paradigm, the experimentation transpires first in the rodent, and then, if applicable, in the human. Now, pluripotent stem cell lineages could serve innumerable functions, and I already alluded to this briefly, not just in IVF. What if you had an individual who was lacking amacrine neurons in the retina? Could we produce replacement cells for that individual and transplant them in a manner? What if you had an individual with Parkinson's disease whose striatum was lacking in dopaminergic neurons? Could we create those neurons and, in principle, somehow transfer them to the affected individual? And where it becomes really stunning, as I alluded to at the beginning, what if we were dealing with a paralyzed individual whose spinal column was severed or in some other way damaged and was unable to walk? Could we produce and introduce motor neurons? And the answer is yes. This very year, in March of the 24th, Nature published a paper titled "Paralyzed Man Stands Again After Receiving Reprogrammed Stem Cells." Now, they're not focused on reproduction. They're focused on neurons, specifically motor neurons. And they were able to replace some of those in an individual whose spinal column was injured in one fashion or another. But enough of that. Let's now go back to our favorite area, that is to say IVF, and talk about in vitro gametogenesis and what it could mean one fine day to IVF. And that fine day, or the date of that fine day, is definitely uncertain. Now, there were early theoretical obstacles to the very idea of in vitro gametogenesis. And that is attributable to what was known and is little known today, the so-called soma germline hypothesis that was developed by August Weismann, who was a professor of zoology at the University of Freiburg, and who published in 1893 the book, The Germplasm, A Theory of Heredity. Therein, he maintained correctly that the germline gives rise to the soma, which is therefore immortal. On the other hand, he argued that the soma never gives rise to the germline, as he saw it appropriately at the time, and therefore is mortal. Now, we know that that very notion is turned on its head when we talk IVG. And so while this was a, shall we say, a theoretical barrier, in reality, it is not. Just to give you a sense on the exposure of IVG, Science magazine in 2021 saw fit to dedicate a full-length review to in vitro gametogenesis, authored, as you can imagine, by Professor Saito and Hayashi. The New England Journal of Medicine, not to be outdone, commissioned a paper from Mary Herbert and Azim Surani, both of them from Cambridge in the UK. who published a paper titled Oocytes from Stem Cell. And yours truly had the pleasure of organizing and chairing a workshop of the National Academy of Medicine in 2023 in Washington, D.C., during which time, over 2.5 days, speakers from all over the world participated, some, of course, via Zoom, including our Japanese friends. And the whole topic, if you will, received a major airing at the time. There's a booklet that was issued thereafter for those of you who are interested. And if I am correct, there'll likely also be a so-called consensus committee report, which may follow. But that committee has yet to be convened. That committee obviously will have to write up a report. So who knows when and if, especially now. Finally, I will mention that the Nuffield Council on Bioethics, which you may know, is the premier bioethical organization of the UK, has made in vitro gametogenesis really top of the line item in terms of its agenda. You know, when you look at their human reproduction agenda, at the very top of the list is in vitro derived gametes. And this is followed by time limits on maintaining embryos in culture, womb replacements, preconception screening, whole genome sequencing of embryos and fetuses, genome editing of gametes and embryos, and egg freezing. But at the top of the list, they placed IVG. And this is a very serious organization that we always pay a great deal of attention to. I think we can all agree that in vitro gametogenesis is a disruptive technology. When did we imagine in our wildest dreams that we could take a skin cell and create an egg or a sperm at will? This simply was not in the cards, but that is changing. Is it achievable in the human? As I'll show you, time still has to tell. We are close, but we don't quite have a cigar. So hold your breath for now. And the timeline is anybody's guess. Again, I would say especially now, when we're not really sure what's going to happen. Now, none of this affects the Japanese counterparts who continue to work diligently and successfully to advance this technology. And it is really thanks to them that one fine day, IVG will become a reality in the US. Now, pluripotent stem cells, and I will cover this quickly, come in two varieties. There's a so-called embryonic variety or induced variety. But whatever we say or do, we have to understand that absent stem cells, we can never get to eggs or sperm, if you will, in vitro. We need to first create the stem cell. The first technology that was used was known as somatic cell nuclear transfer, or SCNT for short. It was developed in 1958 by John Garden from Cambridge University, who used frogs in his early experiments. Specifically, he took an enucleated somatic cell, combined it with a oocytic cytoplasm, and created a zygote, blastocyst in a cell mass, etc., from which he harvested embryonic stem cells. So this was technique number one to create pluripotent stem cells that could, in theory, go anywhere. In 2006, the so-called induction technology was introduced by Shinya Yamanaka, MD, PhD, also from Kyoto University, I might add, wherein they, by the way, have a marvelous stem cell institute. He started with a somatic cell, and he transfected that somatic cell with several transcription factors. Now, I make it sound easy and quick. He spent years figuring out which how many, when, etc. But at the end of the day, he came up with what we call induced pluripotent stem cells. And when we speak today about pluripotent stem cells, effectively we talk about induced pluripotent stem cells because we can make them in the lab in unlimited quantities. And they're just as good as the embryonic stem cells, but there's no need to go to all that trouble if we can create it far more simply. As you can imagine, both individuals received the Nobel Prize in Physiology and Medicine in 2012. There is little question but that induced pluripotent stem cells are a major actor in science and in medicine. And all of us need to pay close attention to what's happening in that arena. Now, if we are to apply these pluripotent stem cells to in vitro gametogenesis, what we're saying is we'll take a somatic cell, say a skin cell, and then convert it to either an embryonic or induced pluripotent stem cells, and let's just say induced pluripotent stem cell, and then guide that induced pluripotent stem cell towards a gametogenic fate. The trick is, how do you do that? And that's, again, where our Japanese friends have excelled. You would need to know certain things. You would need to know the cues that you would have to apply to that induced pluripotent stem cell. You'll need to know the sequence by which those cues are applied. You'll need to know the timing thereof. And you'll need to take into account, in the case of eggs and sperm, the niche in which they are encased in vivo. After all oocytes develop in the presence of granulosa and theca cells, and sperm develops in the company of Sertoli cells. And so to imagine that we could do all that we wish to do in the absence of these somatic cells, which I refer to as the niche, is, again, unrealistic and therefore has never really been pursued as such. The beginning was very modest. Best I could tell, the first paper of some relevance here was a science paper in 2003, which was published, senior authored by Hans Schöller. Hans, at the time, was a postdoc at the University of Pennsylvania. Since that time, he became the director of the Max Planck Institute for Molecular Biomedicine in Germany. But he, early on, when a postdoc in the US, tried to work on this subject. In 2003, Toshiaki Noche from Japan published on the proceedings of the pages of the Proceedings of the National Academy of Sciences a paper titled "Embryonic Stem Cells Can Form Germ Cells in Vitro." And in 2004, in Nature, George Daly, who is now the dean of Harvard Medical School, published a paper titled "Derivation of Embryonic Germ Cells and Male Gametes from Embryonic Stem Cells." And René Rehopera, then at UCSF, published a paper in Human Molecular Genetics on the same. As we observe the evolution of this topic over the next decade or two, you can tell that some very significant papers see press in Nature, in Science, and in Cell. In other words, everybody understood that this is important, that the science needs to be of high quality, and that's what it was. Later on, between 2010 and 2020, again, a series of relevant papers, in this case in the human, in Nature, Cell, EMBO, and others, wherein this notion was further explored. And so when we get to about 2015 and we look at where are we, what was the state of the art, we can say that the germ cell specification pathway is definitely not conserved between the rodent and the human. We can't just copy the rodent and expect it to deliver in a human. We also learned that the genetic networks involved are quite distinct as well. In a word, while we understood how to take embryonic stem cells or induced pluripotent stem cells to primordial germ cell-like cells, the very beginning of the process, we really couldn't produce haploid post-meiotic mature gametes, which is the goal of the exercise. In a word, we mastered the extragonadal component, but we did not master the intragonadal component thereof. The final frontier really was in vitro gametogenesis all the way. Enter our friend Katsuhiko Hayashi, who in 2016, I think while we were at the ASRM meeting in Salt Lake City, published a paper in Nature titled Reconstitution in Vitro of the Entire Cycle of the Mouse Female Germline. So we're still in the rodent, but we can now make it happen. What he did is start with stem cells, combined them with somatic cells, ended up with primary oocytes, eventually M2 oocytes, which are shown on the right left-hand corner here. And from there proceeded to develop blastocysts and eventually pups. In a word, he took the process all the way, albeit in the rodent. Similarly, in vitro reconstitution of the whole male germ cell development for mouse pluripotent stem cells was accomplished by Michinori Saito, now well familiar to you and published on the pages of Cell Stem Cell in 2021. Now, all of this is necessary, essential, fine and good, but what we care about is the human paradigm. And the bottom line is that we're working on it. We're not there yet. But knowing the power of the people involved, somehow I have few doubts that it's just a matter of time before this really happens. The closest we have come on the female side is shown in this science paper published in 2018, senior authored by Michinori Saito, titled Generation of Human Oogonia, not M2 oocytes, Oogonia, from induced pluripotent stem cells in vitro. The process was the usual one. They started with primordial germ cell-like cells, combined them with somatic cells, and guided those stem cells all the way to oogonia, but not to M2 oocytes. And we still have to show the same for spermatozoa. So human in vitro gametogenesis still has some question marks behind it, but it's on the way. And I am certain that some of the younger members of the audience will be around when it happens. Whether or not some of the more senior members of the audience will be there is open to question. But will it happen? Yes. When will it happen? Time will tell. Now, if it happens, the scientific and translational promise is staggering. And you can strain your imagination and come up with virtually any possibility. But in terms of the advancement of science, for the first time in human history, we will have an inexhaustible supply of germ cells. You could have 96-well plates all over the place and study them to your heart's delight. You could do what scientists call functional or non-mutant analysis, which is to say, they knock out one gene at a time and ask, what did it do? Or what is the function of that gene? What have we learned? And you could study more elegantly germ somatic cell interactions, which currently we do our best with, but we are clearly limited. Even more importantly, since all of us are on the clinical side of things, we could potentially reverse germ cell failure, and the imagination roams far and wide here. But in the simplest term, we could provide autologous gamete replacement to individuals who don't have those. We could gene edit gametes if they are, for one reason or another, genetically insufficient or defunct. And for the first time in human history, and that's a separate lecture, we are about to witness, and the young people in the audience are going to be living in that reality, wherein same-sex couples will become the genetic parents of their children, not the adopting parents of their children. And there is a Nature paper which you may want to look at by our friend Katsuhiko Hayashi in February, I believe, when he shows exactly how this can happen in the experimental context. This is very interesting and very different. And the notion of Adam and Eve, I think, is being frayed at the edges. It's still the dominant majority of couples in the United States and elsewhere, over 80%. But there is a significant population of same-sex couples who are now looking at the prospect of becoming the genetic parents of their children. Now back to IVF. In theory, and we're not there yet, we could eliminate the need in gonadotropin stimulation and egg retrieval. Why? Because we could take a skin cell and produce as many gametes as we want. We won't have to inject women for 10 or 12 days, and we won't have to subject them to that surgical, minor, if you will, procedure of retrieving eggs, because we will have essentially an unlimited supply. And we could also, in theory, do away with so-called gamete donation. After all, we have banks out there that we draw upon for eggs or sperm. But if that becomes very doable and accomplishable in your institutional setting, that may no longer be necessary. And in many ways, not in every way, this will convert IVF to a laboratory procedure. I say in many and not every because you will still require endometrial preparation, and you still need to transfer the resultant embryos. But much of the preliminaries up to that point could, in theory at least, be truncated, modified, and therefore make it easier for the couples, especially the women who undergo IVF. Now, I mentioned this as the last point, the notion that maybe this could improve affordability and therefore access. I don't have to tell you that IVF is expensive. You better be insured. You better live in a state with a state mandate. But only 20 states have a mandate as we speak. And so in theory, IVG could, time will tell, reduce the overall cost of this technology. Now, having now lived in the United States for 50 years, I observed the uncanny talent of Americans and American business to jack up the prices, to keep them high, and to never really reduce them. And so as I say all of this, I say this tongue-in-cheek and with a big question mark, because even though in principle, it probably should make IVF more affordable. I'd like to live to see it. Now, as is true of every new technology, you can't just start using it, imposing it on unsuspecting patients. There is regulation. And in the US, up until recently anyway, FDA was the final adjudicator. And under normal situation, IVG would have come under the supervision and review of the Center for Biologics Evaluation and Research, or CBER, which until last weekend was led by Peter Marks, MD, PhD, for many, many years, until he was asked to resign by the current Secretary of Health and Human Services. I spoke with Peter on Saturday. This was a stunning development, but no more stunning than much of what we see almost every day. But what normally would have happened is that IVG would have come under the watchful eye of CBER, which until recently and for many years was under the leadership of Peter Marks. They, in their own lingo, would refer to IVG as human cells, tissues, and products, or HCT/Ps for short. That's just the FDA lingo, and that I assume will persist. Now, you may wonder, why in the world is all of this only happening in Japan? Well, as you know, and all of this is also, this is not news. This has been true since 1996. In the US, NIH, by dint of a rider, which I will share with you, is prohibited from funding embryo-related research. This is known as the Dickey-Wicker Amendment, which was passed in 1996 and prohibits US publicly funded, that is to say NIH, embryo research. So even if the NIH had the funds, wanted to fund it, they can't, because they'll be breaking the law. Unless this amendment is somehow withdrawn or removed, but it has been religiously attached to every federal budget ever since 1996. We lost Mr. Wicker some time ago. He was a congressman from Arkansas. Mr. Dickey is still a senator from the South. He's still very active. And so to this day, the NIH is prohibited from conducting research with public funds. Now, could it be privately funded research? And the answer is yes. And while we don't know much about it because of the secrecy of the companies involved, there are now 2 companies that are producing, if you will, gametes to order. One of them is known as Gamito. It's New York-based, and they just received FDA IND clearance for their product, which they refer to as Fetilo, which will be the first stem cell-based therapy to enter a US phase clinical trial, first 3 clinical trials. So the private sector is trying to make up for what the public sector is disallowed from doing. There's another company which I neglected to include here, which is also in this business. And so it's coming at us from 2 directions. So the possibility of induced pluripotent stem cell-derived gametes is upon us once it's FDA approved. assuming we retain the FDA, we retain all of that. At this point, I'm making no assumptions. But there is still private enterprise activity in this area. And one fine day, I have little doubt, as I said, that the young members of the audience are going to be privileged to work with stem cell derived gametes, which offer all kinds of advantages, which I tried to outline today. So I'm going to stop here because I think we want to leave some time for questions. Plus, this is too tantalizing to entertain. And so some realism, I think, needs to be injected. So thank you very much, Andy, for the privilege. And thank you for the opportunity to bring you as up to date as we know on a field that is making a headway now. And in my view, it's just a question of time.
Oh my God.
I'm sure you've seen there's like this multiple piece series in the New York Times right now about how a society we're thinking about the moral status of an embryo and, you know, what we can and can't do. And a lot of the second piece focuses on PGTP. So screening for polygenic conditions, which clearly at this point, the technology is not matching what some of these commercial companies are offering. But I think that, you know, the theme of all of this is it will potentially and in a short course. What do you see in terms of, you mentioned we will have an unlimited supply of germ cells. Kind of how do you see that playing out and potentially the creation of then an unlimited supply of embryos to, you know, identify those that are most desirable, however you define that?
Well, I hate to do this too, but if you can paraphrase the question for the people.
Well, I mean, it will be a new day when gametes are no longer a rare resource. Where we do have 96 well plates loaded with gametes that are ready to go. So, as I said, it's a little difficult to imagine today, all of us who were around when IVF became a reality, would have never imagined that we would be where we are today. But thanks to Mitinori Saito and Katsuhiko Hayashi, who I wish could be here, we're really looking at a very different future. And gametes, cherished and important as they are, in the final analysis, there are, if I may use the term, consumables. People want to have children, and not just heterosexual couples, but as I mentioned, homosexual couples. So to me, this ultimately is a natural evolution that we all have to get used to, because we weren't born into a world that either had IVF, that entertained same-sex parenthood, but life moves on. And if we are the open-minded individuals we claim we are, we ought to accept, if not embrace, the possibility of making categories of people who were up until now deprived of the pleasure of raising children. We should embrace them and the technologies that make it possible. And I happen to be friendly with quite a few of those couples. And I mentioned this to them, and they can't wait. But they're going to have to wait. And I don't even know how long. But it's on the horizon, and the question is only when, not if, in my view. Unless we turn into Hungary or some such country where we can no longer do what we need to do. Valerie, I'm sorry.
So obviously, we're, very, very excited about this. We see, women with premature ovarian insufficiency who
Yes.
can't conceive even in their twenties with their eggs. And we see men with Sertoli cell only. We see definitely the potential or women who are older and can only have, create embryos that are aneuploids. So I think the potential is there. And I would like so much want to get in on these clinical trials.
I know.
Now, the concern I have is how can we make sure that it's safe? Because if we go back to that paper in the rodent fine print, one small paragraph, these were not normal pups. They had anomalies, there were problems with them.
Mhm.
And as we kind of, like, I'm just thinking to Hopkins IRB, how do I even like start to navigate that?
And we're the open-minded.
Yeah.
Yeah.
So excited about it. I think, egg donation, adoption are not options for everyone, right? And same-sex couples, as you mentioned, but I'm thinking, how do we ensure the safety?
Absolutely. And we're not talking about proceeding willy-nilly to transfer those newly derived human gametes. They'll have to be studied carefully. That's why we have the FDA, or had the FDA. And we will need to convince ourselves that what we're doing is safe. When you stop and think about it, when it comes to IVF proper, we never really did this in a systematic fashion, if you will, a priori or upfront. We figured things out as we went, and we fixed things up to the degree that we could. But the notion of doing a systematic review of these gametes is perfectly acceptable, perfectly necessary. You can never send it on apply it to unsuspecting parents, future parents, without what you just said. So I'm not, and I hope I didn't come across as saying this is done deal. Let's do it tomorrow. We're nowhere near that. But still, as we think conceptually about reproductive endocrinology as we know it, it will transform. And so I'm very excited about it simply because, one, I'm so impressed with these Japanese investigators, with whom I stayed in close touch over the years. And I'm so impressed by the promise of the technology that I think it's essential that we talk about it today, even though we all recognize it ain't going to be here tomorrow. But let's get acquainted with a potential new friend who may not be here in your professional lifetime, but maybe your daughter, who is, I understand, becoming a physician. And if she chooses OBGYN, and if she chooses reproductive endocrinology, she might be the one to embrace this development.
It's on the line of safety, but also efficacy. So if you do have a new oocyte that you have developed through IVG, and we currently don't have a really good parameter to call a beautiful, good embryonic potential oocyte that we don't use currently, what would those parameters look like for IVG development? And what would those opportunities look like in the process to define a good oocyte, just in terms of its quality parameters, but also its embryonic potential?
Yeah. Well, first of all, I would say we need always start with a rodent or an experimental model before we rush into the human. But yeah, these gametes will have to be examined top to bottom. They will have to be sequenced carefully, and any potential pathology, genetic or otherwise, identified before we obviously impose it on people. But that's exactly, first of all, what needs to be done by independent investigators or by companies who are developing. But more importantly, this will be probed very carefully, or should be probed very carefully, by the FDA or whatever ends up being the future arbiter of these technologies. Yeah, I was quite distressed by the changes at the FDA, which up to this point was relatively immune from the upheaval. But when I saw the headlines, I really was beside myself. Yeah.
Well, I don't even know what to say. Sir, good to see you. I think what's mind-boggling is it's only been 40 or 50 years. And it's amazing how much has happened in such a short time. And so it's not hard to imagine what could happen in the next 40 years. I mean, I'm just, that was a fantastic talk, and I'm so glad to have so many people here in person. It's great to have you back where you belong or where you started. And I think to everybody, for the young people in the room, I mean, this happened in the time of people's careers, like professional careers. So, set the goals high and don't let people tell you you can't do it. I know the sky is proverbially falling right now, and it's been falling for 50 years. It hasn't hit us on the head yet. It does feel a couple inches closer, but just keep going. I mean, just keep going. And I'm sure there's things that you mentioned today that we will see, and there are things that we haven't even thought of that we will see. Now, if we could just figure out how to prevent preterm birth, I would be really thrilled with that.
I'm on your side.
Yeah.
I would also say, we haven't mentioned this, but this came up recently. Since you're really not limited in terms of the starting material, what about individuals who, in theory, concluded their reproductive life cycle? Could they contribute a skin cell and redevelop gametes? I mean, the possibilities are just mind-boggling. And so much of the rest is not so much science. It's more ethics, religion, personal preferences, and the like. So the day of menopausal pregnancies, I haven't yet brought that up, may not be out of the question.
Oh, please, no more 65-year-old pregnant women. I don't think I could deal with
All I would say is
that.
you will be the one communicating it to these women.
All right. Well, listen, everybody, thanks for so many of you being here in person. It's great to have people in the room and not just on Zoom. Have a wonderful Hopkins day. And if you want to stay around, for Dr. Hadashi will answer some questions. That was wonderful. I don't know how we can stop share. Sorry, you're gonna have to get us out of here this time. Yeah, I should. Well, that's one way to do it.
That's what we're doing now.
What's the course here?